Writing function rules from tables, Unit 9, Day 1. Okay, so the way I'm going to try to go about this to begin with is just like I'm solving a puzzle, because that's really all math is solving puzzles. So I need to complete each one of these tables, write a function rule to model the data in the table. So really, I'm trying to come up with a pattern. What can I do to the x's to produce the f of x's? Okay, so the first thing that I automatically almost always try is, could I add this? So 1 plus 2 would give us 3, right? Let's see, will that work down here? 2 plus 2, will that give us 6? No, it won't. Okay, so now I might want to try, let's see, well, can I multiply something? Well, let's see, 1 times 3 would give us 3. 2 times 3 would give us 6. 3 times 3 would give us 9. 4 times 3 was 12. Okay, so we see a pattern here. So my f of x, I have a feeling it's going to be 3x. So take your inputs, multiply them by 3, and gives you the outputs. And that actually works, plain and simple. If I plugged 1 in there, 1 times 3 is 3. 2 times 3 is 6. 9, 12, and then I continue, I get 15. 6 times 3 is 18. 7 times 3 is 21. 8 times 3 is 24. Okay, and there we have it. So the function rule for in this case is f of x equals 3x. Okay, let's try number 2. Again, the first thing I want to see is what could I add? So from -3 to -6. That's more like adding a negative, subtracting. Subtracting 3, it looks like. So let's see, will that work? If I subtract 3, so 3 minus 3 gives us that. -1 minus 3 is -4. Okay, good sign so far. 0 minus 3 is -3. 2 minus 3 is -1. That actually does work out. So I'm going to begin my function rules. F of x equals x, my input, minus 3. And like we said, that actually takes care of these. So let's continue that. 5 minus 3 is 2. 7 minus 3 is 4. 10 minus 3 is 7. 13 minus 3 is 10. Okay. Next, I want to show you a little bit more methodical ways to kind of go about this. So we can actually tie back in because everything we've looked at so far and everything we're going to look at today is all lines. Okay, and we're going to end up with something that's y equals mx plus b. Okay, so if we can figure out what the the slope is, and the y-intercept, then we're taken care of. So I'm going to look over here to see if I can find the change in y, the f of x, and then the change in the x's, and see how those compare. So let's see, that's going up by 0.5, here, up by 1. 0.5 divided by 1 is 1/2. So I'm going to have 1/2 x, that's my slope. Now, only question is, does that take care of it, or is there something I need to add or subtract over here? So 1 times 1/2 is, well, 1/2. 2 times 1/2 is 1. 1/2 of 5 is 2.5. 1/2 of 10 is 5. Okay, that actually takes care of it. So that is actually our function rule completely. Okay. So let's see, if I do that, 1/2 of 12 is 6. 1/2 of 15 is 7.5. 1/2 of 17 is 8.5. 1/2 of 20 is 10. Okay, let's check out number 4. Okay, now the first thing I notice when I look at number 4, before I do anything else, is if I'm trying to find the equation y equals mx plus b, my y-intercept is already showing right here. I have 0, 0. So in my equation, I'm going to have something x plus 0, which I don't have to write that part, but that's what I'm going to end up with. So I know my y-intercept already. So now just as a matter of fact to see how the y's and the x's are changing. So let's see, how about from 1 to 0? That's minus 1. From -1 to 0, it's plus 1. So change in y divided by change in x, our slope is -1 over 1. Which is just -1. So -1x. So f of x equals -1x plus 0. Okay, so let's just think this through. -2 times -1 is +2, plus 0 is 2. Negative 1 times negative 1 is positive 1, plus 0 is 1. 0 times negative 1, 0, plus 0, 0. Okay, 1.4 times negative 1 is negative 1.4 plus 0, negative 1.4. Okay, so effectively we're really, because this is optional, we are really multiplying whatever it is by negative. So changing the sign here. So we get negative 9, negative 12, negative 15, negative 33. And that's the most methodical thing you can do to go through this. Find the slope, changing y over changing x, and the y-intercept. Alright. Now if all's going well, you're going to try some on your own. Alright, so those of you watching at home, let's carry on. Let's see. So the y-intercept is actually showing on number 5. In fact, it's also showing on number 6. If you go ahead and circle that, we know there's our y-intercept. So I'm going to have f of x equals something x plus 0. Which, again, I don't have to write that. I could just write something times x. Let's see. Negative 3 times negative 4. Well, that would give me negative 4x. Okay, but if I do it this way, I'm going to look down here. Minus 4 plus 1, 4 over 1 is negative 4. Negative 4x. And again, negative 3 times negative 4, 12. Negative 2 times negative 4, 8. So negative times negative is positive, right? So we get positive 4, 0, negative 4, negative 8, negative 12, negative 16. Alright, number 6, we already have the y-intercept, so we know when it comes down to it that we're going to have f of x equals something x minus 1, because that right there, minus 1. So let's see how about the slope from here. Negative 1 to 1 is up by 2, up by 1 in the x's, so m is, it's always the change in y over the change in x, so 2 over 1. So our slope is 2, so we have 2x minus 1. And you could actually test this out. If you took negative 2 and plugged it in there, you get negative 5 out. Negative 1, so that's negative 2 minus 1, negative 3, etc. So 4 times 2 is 8, minus 1 is 7. 10 minus 1 is 9. Okay. So let me just glance through these next 3. You see the y-intercept. You ought to. It's when so the y-intercept, I always said this, the y-intercept is when the x is here. It's always 0 comma something. Okay, so 0 comma b. We often say y equals x plus b. Those two are always the same. So 0, 1, so we'll have a plus 1 at the end. 0 minus 4, so we'll have a minus 4 at the end. 0, 0, we'll have a plus 0. So just go ahead and write these equations out here. Something times x. This one is going to be something x minus 4 equals something x plus 1. So let's look at our slope now. We have up by 3, up by 1, 3 over 1. So our slope is 3x plus 1. Now plugging these in, 3, let's see, that gives me 9 plus 1, 10. And actually, because the slope's 3, they're going up by 3s every time. So we get 13, up by 1, so up by 3 more, 16. And by 3, we get 19 there. Okay, number 8, we still need to find the slope here. So let's see, this is going up by 3, up by 1. So our slope is 3 over 1, or just 3. So as we go up, we should just be going up by 3s. 3 minus 4, negative 1. Oh, sorry. 3x minus 4. I didn't write it up there. I didn't actually fill in the blank. Be sure you don't do that. 3, so that's 9 minus 4 is a 5. 12 minus 4 is 8, so it's up by 3. 15, 11. And there we have it. So number 9, we looked at this. We've already have the y-intercept is 0, 0. There is a y-intercept. You just don't write it. It's just 0, 0. So going up by 1, up by 5, delta x is 1/5. So we have 1/5 x. Now look at it. Make sure the pattern makes sense. -10. A fifth of that divided by 5, you get -2. A fifth of -5, -1. A fifth of 0, 0. A fifth of 5 is 1. A fifth of 10 is 2. A fifth of 50 is 10. Yeah. A fifth of 100 is 20. And there we have it. Okay. Now we're going to carry on the same idea looking at the rest of this. Okay. So we're going to see this in a slightly different context. Write the equation of the line with the given table in slope-intercept form. Then graph the linear function. So we know that our equations are always going to look like in the end y equals mx plus b. So first thing I want to notice is my y-intercept. Every one of these should be immediately obvious. Actually, yes, 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 all of them. The y-intercept will be immediately obvious. 0, something. So our slope. Just look how much this changes. So going up by 1, up by 1, and by the way, surely someone has already asked this, but yes, you could actually use the slope formula. M equals y2 minus y1 over x2 minus x1. You could use that. Because I have tables, it's more convenient to actually look at the change in y, the change in x. So 1 divided by 1, we get 1. So our slope is 1. So that means our slope formula, we have y equals mx plus b. So m, our slope, x, plus b, our y-intercept. So 1x plus 5. Let's see, so 0, 5, 1, 6. Yep, has a slope of 1, up 1 over 1. And it starts at 5. Okay, so it will continue over something like that. I started digressing on my line there. Let's see. That's a -5. Down 1 over 1, down 1 over 1. Okay. So there. That's a little better. Alright. Let's look at our next one. Okay, first thing, what's the y-intercept? You see it? Hopefully you see it right there. 0, 2. Okay, so just need to find the slope. Let's see, up by 2, up by 1. So it is 2 over 1 or 2. So we get y equals 2x mx plus b, so plus 2. So it starts at 2, goes up 2 over 1, 2 over 1. Ooh, that line is not turning out too well for me. There's a lump in my box here. Right there. Alright. So hopefully this matches up at points. Let's see, -3, -4, -2, -2. 1, -1, 0, right there. 0, 2, 1, 4, 2, 6. Yep, that matches up all our points. Alright. Y-intercept. There it is, 0, 0. Later in the year, we're actually going to refer to something like this where the y-intercept is 0, 0 as a direct variation. And they actually kind of have a lot of special applications of those in particular. But let's see. So if we have that, then we can actually notice the pattern right here. Negative 1 times 3, 1 times 3 times 3 times 3. So our slope is actually going to be 3. Now, we wouldn't draw that right there. 3 divided by 1 is 3. So y equals 3x. So we're going to start right there. It goes up 3 to the right one, or down 3 to the left one. What happened to my line there? Oh, it got off toward the end. As long as I know my points are perfect, then my line doesn't matter a whole lot, but it should look like a line. So, I see what I mean. I see what I did. I started going to the left a little too far. Oh well. Alright, number 13, y-intercept. Bingo. First point on the table. Oh, I didn't notice until now. If you notice our functions, some of them are named differently. This was t of x. We had a of x earlier. F of x. F of x. But really, this is just a name. In fact, I saw somewhere where people were actually naming their functions. This one not. Let's talk about Timmy. Timmy has a y-intercept of 0, 4. He has a slope of, let's see, down 1 and to the right 2. So negative 1/2. So he starts there, down 1 and to the right 2, down 1 to the right 2, 2. Okay. And this one is bound to be a little off. Let's just make sure it's in the vicinity for this. So 10, negative 1 actually would match up right there. 8, 0, 6, 1, 4, 2, 2, 3. Actually, this line matches pretty closely to my points there. So that is y equals negative 1/2 x plus 4. Two more to go. So d of x. I can't think of a name right now that starts with a D. Diana? Sure. Our y-intercept of Diana is 0, 0. Let's see. Our slope looks like we're going down by 1 and up by 1. So our slope, changing y over x, so we get negative 1 over 1. It should just be negative 1. So we start right here. Down 1 to the right one. Down 1 to the right one. And we're going to end up way over here. But let's just make sure I match up on points. Negative 3, 3. Let's see if I went back the other way. I'd have some points this way. So negative 3, 3. Negative 2, 2. Negative 1, 1. 0, 1, negative 1. 2, negative 2. Yep, this will match up all my points. See if I can. That'll work. So in slope-intercept form, y equals our slope, negative 1, x plus b. So I could write plus 0. Okay, I could write that, or I could just write that, not write the plus 0 in the end. Alright, last one. Do you see our y-intercept? Got it. 0, 1. Okay, and I'm just going to look and see my slope again. Let's see, I'm rising by 1. So that's like going rising 1 and going to the right 3. So rising 1, right 3, that's 1/3. So y equals 1/3 x plus 1. Let's see, plus 1. There's our starting point, up 1 over 3, up 1 over 3, up 1 over 3. Just make sure these match up. 0, 1, 3, 2, 6, 3. Okay. Let's see, negative 3, 0. That would be me going down 1 to the left 3. Down 1 to the left 3. I get it to negative 6, negative 1. And negative 9, 2. Or negative 2. So that one matches up as well. Whoa. There we go. Alright, and there we have it. Really all there is to this is finding the patterns. Okay, if you recognize patterns real easy, then you like playing things like Sudoku and things, you might pick up on writing these equations pretty quick. Alright, let's go.